and it's now time to look at compound equations and inequalities quiz 2. How many solutions does the following equation have? And we're looking at this one right here with a y on the left, a y on the right, but we've got to deal with, first of all, the distributive property because we want to make sure we can work with that y on its own. So we're going to bring that outside of the parentheses that it's trapped in. And now we'll look at this. How many solutions, how many solutions, how many solutions? We do notice that there's a 4y over here and there's a 4y here. So something's funny about that. Well, we can basically not guess. We can just subtract 4y from both sides. We just it's an equation, right? So we can continually go back to our principles. We get 0 minus 120 equals basically 0 plus 12. In other words, we get something like this. Negative 120 equals 12. So, well, if you think about that, it doesn't make a whole lot of sense, does it? If that were dollars, where in the world would anybody agree to being $120 in debt as opposed to being $12, having $12 in your pocket? I mean, maybe in a non-capital, maybe in a communist country, I don't know. Somebody could maybe convince you that having less money or no money or even being in debt was better than having money. In some cases, yes, but in this case, mathematically, the numbers basically say this is false. It's a false statement, and therefore there's actually no solution because there's nothing there's no value of y, or any variable for that matter, that is going to make this anything other than being false. So that's how that works. If you get something that's absurd, once you work it out, then you're going to just put false, no solution, because there's no money, there's just no number that you could put in for y or substitute in for y. I could put y equals 3 and you'd get 12 plus 12 is 24, and we'd get 3 minus 3 is negative 27 times 4. We'd get negative 100 something would equal to 12. Again, that would be false. No matter what you put in for y, we put y is 1, we're going to get 16 on the right, we're going to get negative, 108 or something on the left. And nothing is ever going to make this thing true. It's never going to get a solution. There's just nothing you can add to, you can make y be that's ever going to change that. So it's false, no solution. What about number 2? We're on number 2 now. Which of the following equations have infinitely many solutions? Choose all that apply. Same idea here. When you get good at this and quick at this, you realize, well, the left-hand side is the same as the right-hand side. Something's fishy. But if you want to do the long route, just keep at your principles, add 10 to both sides, and you get negative 10x equals negative 10x because those become 0. And again, this side equals that side. If we wanted to continue, you're going to get x equals x. Well, hold on a second. If x equals x, that means if I were to put an example here, I could say 5. If x equals 5, then 5 equals 5. Well, what is that? I mean, that doesn't tell you anything other than what you know, which is that it's always true. This is always true. So these kinds of questions are infinitely many solutions because no matter what solution we choose, okay, it's always true. If I took x equals negative 5, I would get the same thing, right? I would also get negative 5 equals negative 5. I mean, I'd get something, the left-hand side equal the right-hand side. So what we say for these are infinitely many solutions. And what does that mean with regard to the question? Well, the question asks you, which of the following equations have infinitely many solutions? We would definitely say that this one does, right? This is definitely one of them, but we can keep going. If we keep going on all these questions and figure them out, we're going to get something like, okay, add 10 to both sides. We're going to get, in this one, we're going to get 10x equals negative 10x, and that is going to be plus 20. And so in this case, this is going to end up being x equals 1, and that's one solution. That's not infinitely many solutions. So that's not going to be one of them. 10x minus 10 equals 10x minus 10. The left-hand side equals the right-hand side. That's in C. Oh, well, okay. Well, in that case, just like we saw at the beginning, we're going to end up with something like if I add 10 to both sides. If I go through the motions, I'm going to end up, no matter what I do, I'm going to end up with x equaling x. Okay, you don't even have to go through this right now. Or 1 equals 1, right? In other words, this is infinitely many because it's always true as well. Infinitely many, and it's always true. It's the same thing as A, so I'm going to say A and C. On this one, these are different, so therefore that's out. We just know that if the left-hand side over here is not the same as this side, it's actually going to be, what you're going to get is, I can tell you, we're going to add 10 to both sides, we're going to get 0 equals 20. We're going to get no solution because we're going to get an absurd statement, and that's how that works. So there you go. A and C are your answers for these ones. For this particular one, which one have infinitely many solutions? The last question on this quiz is, again, you have to deal with your distributive property in order to solve this. I actually don't know what they said to solve this for. Let me double check that. It says assume the equation has a solution for z. Okay, so we want to solve for z in this one. And since we need to get z alone on one side, we got to get it out of these parentheses. So we got to distribute. We're going to get negative 51p once we distribute it, minus pz, one way to put it, equals dz plus 84. Now these are actually pretty tricky because you don't have, well, first of all, you got to keep following the principles you know, which is to make sure all the z's are on one side and all the numbers are on the other and then letters are on the other. So everything else has to go on the other side. I'm going to add 51p because it doesn't have z in it. We don't care about p, really. We don't really want to, we don't really want to deal with it. We want it just to be gone over on the other side. So right now we have minus pz equals dz plus 51p plus 84. Doesn't seem to be that much simpler, but we do see that there's a z on this side kind of appearing on the left. We can also subtract dz here, if that makes sense to you, because what do we do to one side? We got to do the other. So we're left with minus pz minus dz equals 51p. I told you this was a little more complicated than it looks. But here's the thing. Once you have this, what you notice is that the z and the z are in common. And you can do what's called factoring. It's a way of grouping things differently. So if I take z out and I leave what is left over and I were to reverse distribute it, if I look at this, the z times the negative p would give me my negative pz. And if I'm reverse distributing, if my z were there and if I did minus d, you would get your minus dz. So what we've done is just sort of manipulate the left-hand side in order to regroup it in order to get z on its own. And here's why. Once you're there, you're almost done. All you have to do then is just divide by minus p minus d on both sides. And this is a mess over on the right. We don't, but we don't care because we're solving for z, and that's all that matters. 51p plus 84 over minus p minus d. Look, there's just, we don't care. If they give us a value for p and d, then we could actually get a number value for z. But right now, we've done our job in this kinds of questions. So this, as I said, these are kind of complicated because there's so many letters involved. A p, a d, a z. But you're solving for z. You just got to be relentless and got to keep going until you get z on its own. And don't forget that everything else has to go on the right, and then you have to get z on its own by factoring out the negative p minus d in this case. So that's common for these kinds of questions. All right, well, that's everything for quiz 2.